Good afternoon, Mathletes. What's up, Math 2? It's going to be a great day. I'm not here today, but I'm still here to teach you. Today, we are going to talk about the magic that is reflections. See if I can write it out there. Reflection. We're talking about transformations is what we're really talking about. That's why today our lesson title is Transformations. And if you look at our learning target over there on the board, it is, I will use transformations to manipulate figures in the coordinate plane. Wow, that's a mouthful. It's also going to be right above this video in your Canvas page if you want to go look at it, or you can look, like I said, over there. But we're not just going to manipulate figures, we're going to manipulate points as well, and we'll talk about that. And the first transformation, we're actually going to talk about, I think, 4 transformations, but only 2 today. So today we're going to talk about reflection and translation. And I have no idea why I put reflection first, because quite honestly, we're talking about translation first. And all translation is, you can see it right, there's the word translate. We're talking about translation. In fact, in your notes, guys, why don't you write down translation? And if you haven't got your notes out, get them out. Write down the learning target. Write down the word translation. And I'm going to walk you through a couple problems. I do want you to draw right here a nice little XY table. Take a minute to do it. In fact, go ahead and pause this. Wait for everybody to take a minute, draw a nice little XY table that you see here. And go ahead and draw this figure. And then we're going to talk about it. Ready, set, go. All right. So here we are, and what do we see right here? It says the figure below has a point marked with a large dot. First translate the figure 8 units down. Well, where's down? It's down here. So we're going to take this, and we're going to drag this point 1, 2, 3, 4, 5, 6, 7, 8. Then give the coordinates of the marked point in the original figure and the final figure. By the way, if you ever mess up, you can always click the X button to start over or undo something you did there. Okay? So, what is the point in the original figure? Well, we see it right here. It's at the point X equals 1 and Y equals 4. So that is 1, 4. And what is the point in the final figure after we translated it down 8 units? It is now still 1 on the X, but negative 4 on the Y. So 1, negative 4. And that makes sense. I want you to think about it. If the original, let me get my controls up here. If the original point was 1, 4, and we are moving 8 down, we're only affecting the vertical or the Y, right? The up and down. So because of that, we would subtract 8 from that 4. And what's 4 minus 8? It is negative 4 because we were just translating down, all right? So this is a translation. A translation is either a left-right, a horizontal move, or a vertical up and down move. You can even do combinations of them, which we're going to look at here in a second. But for now, this is a basic translation. And we can always check this. Oh, it didn't make the nice sound, but you know what it did do? It tells us we're correct. So I want to look at problem number 2. And again, this is just right out of your homework. You'll have different ones, but I want to give you examples. Go ahead and just draw this on the same exact set of axes you were just using. Really, the only thing I'm going to pay attention to is this point. So if you just want to mark the point 1, negative 5, which is going to help us right here. The point in our original figure is 1, negative 5. And I want to show you what happens when we end up doing a combination. So it says first translate 8 units to the left. So we're going to go 8 units to the left. 1, 2, 3, 4, 5, 6, 7, 8. And what does it say? 7 units up. 1, 2, 3, 4, 5, 6, 7. What is our new coordinate? Well, let's see what we did. We went to the left 8 units. Remember, horizontal affects it affects the x, the horizontal, the x. So we're only affecting the x figure with the 8 units to the left. So if I'm moving left, that's getting negative, which means I'm subtracting. So I'm actually going to take my, let me redraw this point right here. It's the point 1, negative 5. I'm going to take that 1 and I'm going to subtract 8. But then I did something else. What did I do? It said move 7 units up. Up affects the y, and going up means we're getting more positive. So we're going to add 7. And let's see what our new coordinate is. Well, 1 minus 8 is negative 7, and negative 5 plus 7 is 2. Boom. Our new point is 7, negative 7, 2. Let's go ahead and type that in. We're going to have negative 7, 2, and as always, check our answer. Boom. By the way, I do want to remind you guys, if you ever get stuck, does everybody see these over here? We have choices. If you hit explanation, it's just going to straight solve this problem for you and then give you a new problem. If you hit example, it's going to pop you up with an example problem that might lead you in the right direction. You just got to scroll down through it and kind of watch what it's saying. So I want to encourage you guys, use those helps. Since I'm not there, go ahead and use those to help you if you get stuck at all, and I will be back tomorrow. All right. And move this over. Let's take a minute, and I want to now skip over to problem 5. We're still doing translations, but now we're going to do a drawing, and I want to demonstrate how to do this. So again, I think you guys got the translation. We're just moving certain places. But if we're translating a figure, we have to translate each of the points. So draw the following triangle after a translation of 2 units to the left and 3 units down. So I'm going to take this point, and I'm going to go 1 to the left and 3 down. 1, 2, 3. Boom. I'm going to take this point right here, and I'm going to go 2 units to the left, 1, 2, and 3 down. 1, 2, 3. I'm going to take this final point right here. I'm going to go 2 units left, 1, 2, and 3 down. 1, 2, 3. Okay, now watch what we can do in here. Probably should erase these extra points I threw in there. Oh, why is it not erasing? Oh, I don't know how to erase it. Hopefully it won't count as wrong because of it. Choose the line tool, and I'm going to connect these points. You have to choose the line tool every time to connect the points. And let's see, I'm willing to bet it might count me wrong because I'd actually drawn. Oh, wait, it got rid of one of those points. We good now? I don't know. Okay, so let's see how we did. You guys ready? There's nothing else below, right? Okay, we're going to check it. Oh, it didn't mark me wrong for those points. So yeah, look at that figure. See how we moved it? It holds the same shape, same size, same angle, same measures of sides and everything, but it's just translated 2 units left and 3 units down. Okay, and the last translation I want to look at is in problem 6. This one is dealing purely with numbers. So here's what it says. In the coordinate plane, the point A, which is 3, negative 2, is translated to the point A prime. Whenever you do a rotation, guys, we call the image where it goes to A with that little dash, which means A prime. Or if I were to translate point B, I'm going to translate it to B prime. C is going to translate to C prime. That's how you would say it. So in this case, I'm going to take A, which is 3, negative 2, and translate it to the point 1, negative 1. Now let's look and see what was done here. Oops, don't know what just happened. Sorry, we had technical difficulties there for a minute, but I'm back. All right. So let's draw this real quick. If I have 3, negative 2, and I told you I translated it, and when I translated it, it went to 1, negative 1. Let's figure out what the translation was. To go from 3 to 1, what do I got to do? I got to go minus 2. So that tells me that in the horizontal direction, I moved left 2. So that's telling me I went left 2. Now, for the y, I was at negative 2, and I went to negative 1. That's actually plus 1, which means plus 1 in the y direction means I went up 1. So if I'm going left 2, up 1, that's the same as taking the original point, subtracting 2 from the x, adding 1 to the y, and then I get my new point. So if I want to know what b prime is, I need to look at the original b, and what am I going to do? I'm going to subtract 2 from the x, and I'm going to add 1 to the y. And let's pull what we get. Oh, sorry. So if I'm going to subtract 2 to the x and add 1 to the y, I should be getting the point negative 1. I'm going to have to write it over here. If I get off of this, it's going to erase this stuff, and I want it to stay. So I'm going to have negative 1, comma, and 0 plus 1 is 1. That's going to be the point we put in. With c, if I subtract 2 and add 1, 7 minus 2 is going to get me 5. And negative 4 plus 1 is going to get me negative 3. So my point's negative 1 is b prime, and 5, negative 3 is my c prime. All right, this is how we work these out. We got to find out what our translations are. It's just a simple move. Now we are going to move on to one of my favorites, reflections. So let's go to we're going to go to problem number 7. In the 7, we're going to start talking about reflections. So in your notes, guys, make sure you write down reflections. And again, draw yourself another set of axes. So go ahead and pause this if you need to. Take time. I want you to draw this and draw this point A, which is located at 6. The point 6, comma, and on the y we're at 5. Just in case you can't see this very well on the screen. So 6, 5. Ready, set, go. And we're back. Hopefully you got this drawn in your notes, because I'm going to be looking for it when I collect notes later on in a week or two. But we have A, and what does it tell us to do? Well, let's look. It says, using the pencil, plot the reflection of point A across the y-axis. Think of a reflection like a mirror, guys. So if the y-axis were my mirror, how far away am I from that mirror? Well, let's find out. I'm on point A. I'm 1, 2, 3, 4, 5. I'm 6 away from the y-axis. And remember, it told me to reflect across the y-axis, so because of that, I have to go towards the y-axis. And so since I was how far away? Let's try it again. Sorry, I lost my train of thought. 1, 2, 3, 4, 5, 6. That means I'm going to go 1, 2, 3, 4, 5, 6. Boom. And my new point, which would be, let me label it just because, A prime. So this original point, what was it? It was 6, 5. And my new point, my A prime, is now negative 6, 5. Does anybody notice what I did in reflecting it across the y? I took the x value and it just became a negative x value. Okay? So let's pay attention to that. That might be something we can look at later to help us. All right. I'm going to go to the next problem. Make sure you have this all written down. Good times. If you want to, we can check it. Did we do it? Yay! And let's take a look at 8. We're going to look at 3 more problems. All right, here's what it says in 8. Just down a little bit. It says the point A is shown below. Reflect A across the x-axis. Again, on that same set of axes, go ahead and draw A. And this one is at the point, let's see, negative 5, 3. So that's at the point negative 5, 3. But this one's a little different. Instead of the y-axis, it says reflect across the x-axis. So we're going to reflect across this horizontal axis, which means when I go to draw the point, I'm going to go over here to point A, and to find A prime, I got to go, it says across the x-axis. All right, so I'm going to go 1, 2, 3. All right, it's 3 away from the x-axis. What does that mean? I'm going to go down. 1, 2, 3. So there is my first move. But then it tells us something else. Then reflect the result across the y-axis. So where am I going to go? I'm going to go 1, 2, 3, 4, 5. That's 5 away from the y. So I'm going to go 1, 2, 3, 4, 5 for my final landing point. And let's check out and write what the different changes did to the point. So first, when I reflected it down across the x-axis, notice the x value stayed the same. It's still 5. So this original point was negative 5. Ooh, what am I thinking? Negative 5 and then up 3. But when I reflected down, the x value stayed the same. It's still negative 5, right? But what's the y value? It's now negative 3. Notice reflecting across the x didn't affect the x value. It just made the y value opposite. In that last problem, when we reflected across the y, it didn't affect the y value, but it made the x value negative. Well, let's check that out, because now we're going to do a reflection across the y. When I reflect this across the y, again, it doesn't change the y value, so I know right away this point is going to still be at negative 3 on the y. But what did it do to the x? It brought it from negative 5 to positive 5. So one thing that's good to note is when we're reflecting across the x. What does it do? It takes an xy point and changes it to x negative y. It's the opposite of whatever the original y value was. And if we're going across, sorry, I'm a little slow writing with my mouse, the y, it takes that xy point and changes it. Remember, it doesn't affect the y, but it changes it to negative, I'll try not to go in the middle of my video, negative xy. Make sure that's all in your notes. Pause it right now if you need to write all this down. Let the sub know when you're done so we can know when to continue the video. All right. We are good to go. Let's go to the next. Move this up a little bit, get everything out of the way. And we're going to take a look at, oh, I didn't check my answer. I probably should have. Oh, it only wanted me to show the final point. Okay, so it didn't want me to show this. Oh, I didn't do that. This is down 1, 2, 3, 1, 2, 3. Ah, crud. Ah, dang it. It's killing me. I have to finish it. 1, 2, 3, and over. Now let's check it. How do we do? Oh, I got it right. All right, just 2 more problems we're going to take a look at with reflections because I want you to see what this does. So in order to do this problem, guys, it says the figure below has a point marked with a large dot. First, reflect the figure across the y-axis. Then give the coordinates of the marked point in the original figure and the final figure. So to do it across the y-axis is the up and down one, so we're going to use this one. And we're going to put it, it says on the y-axis, so we're going to click on here and see how that auto reflects it, guys. So then let's go over here. What's our original point? Well, it was at negative 7 and down 6. So negative 7, negative 6. Negative 7 and negative 6. What about our final figure? Well, since I went across the y, remember it shouldn't affect the y value, but it's going to make that opposite. So without even looking here, I know it should be 7, negative 6. Let's see if that's true. 7, -6. Look at that. And I bet when we check it, we're going to get that nice, shiny little green. Yeah. And our last problem we're going to work on, guys, just as a final example that I was looking at and wanted to make sure you guys had it. What happens if we're not given a graph? Well, what do we know? We know if it's reflected across the x, it doesn't affect the x. It makes the y opposite. So what should this be? It should be -6. And then make the y opposite to -7. Same thing down here, reflected across the y won't affect the y, but will make the x opposite. So now it becomes 6, and 7 stays the same. Awesome. So I want you guys to work through as many of these problems as you can. When you start getting to the rotations and other type of transformations, go ahead and do your best. You can always, like I said, see if you can problem solve yourself by either having it explain how to do the problem it gave you, or I would say to start off with an example and follow that down and see what's going on. With that said, peace out.